What we will study now is the second part of transformer. What happens to electric current in transformer? Does it increase, decrease? So first, when we are giving energy on the primary side, we are taking energy from output, that is secondary side. According to conservation of energy, we can never gain extra energy from any process. So energy given is equal to energy taken out. This is according to conservation of energy. So according to conservation law is equal to energy received. Now energy given in the input is E at the primary multiplied by current at the primary. This is equal to energy received at the secondary, which is in the form of E in the secondary multiplied by current in the secondary. So this is our basic guiding formula. And what is this? Energy. Now according to this, we can find that EP upon ES is equal to IS divided by IP. But we know that EP upon IS is equal to NP upon NS, that is number of turns in primary, number of turns in secondary. So this is the relation, and we pick up this part of it. So this is current in secondary, current in primary. So current in secondary and primary have the ratio number of turns in primary divided by number of turns in secondary. It is inverse of that ratio what we get for EP or ES upon EP. So this is our relation for IS and IP. So current in secondary is equal to NP upon NS multiplied by IP. Now let's discuss the two cases. There is one transformer which is output is higher voltage. What do you call it? Step up transformer. In step up transformer, number of secondary are larger than number of primary. So how will be the secondary current? Answer: if this is small, this is large, then IS will be smaller than IP. This is a small fraction. See here, if NS is large, IP will be large. Okay, so IS will be smaller if it is a step up transformer. In step up, what happens in step up? Normally E increase. But what is happening to current? This is larger, this is smaller. So current is getting smaller. Current in step up transformer, current become less, decrease. And reverse to this, in step down. In step down, we know NP is larger, so current will increase. E decrease, current increase. So you have seen this mathematically. If we are giving current from here, this current will be larger. Why? Because we have to maintain energy. If ES become larger, then current has to be smaller. If ES becomes smaller, current has to be larger. So the ratio of current is inversely to ratio of EMFs, ratio of voltage. So this is what happens in current. Now if I, for any of my purpose, I want high current, then what should I do? I should decrease the voltage of the same supply. How do I decrease the voltage? I use a step down transformer. So when I use a step down transformer, voltage will decrease, the current will increase. And when the current increases, heat will be increased a lot, and I need heat for welding purpose. So I will use a step down transformer. We will come to that when we are studying uses of transformer. So this is the current equation. Now we will see where do we use the transformers. We will study the application of transformers, and the first application is we use transformers for AC transmission. Why do we use, how do we use transformer in AC transmission? For that we must study the transmission problems in alternating current when we are sending energy from one location to the other location. Energy is okay, from one location we are sending energy to another location through the wires. These wires have got certain resistance. When the current passes through this, then we see a lot of heat is produced, and that heat formula is I²R. Larger is the current. If the current increase say 4 times, how much the heat will increase? Answer, heat will increase 16 times. So the current issue is very sensitive when we are sending, and we want that current should be as small. Now suppose I want to send certain power. That power is equal to E into I calculation. This is 1000, this is 1000, and how much is the power? 10 to the power 6, that is 1 megawatt. 1 megawatt power I want to say. Now how much is the heat produced? Heat produced is I², that is 1000 square multiplied by whatever is the resistance R. This is 10 to the power 6 R, and this is my loss. After this loss, this power reaches here. Okay. Now suppose the same power I use a transformer. This I increase up to 1 lakh volt, 10 to the power 5 volt, this voltage, and this is current. If the same power I increase the volt with help of transformer from 1000 to 1 lakh 100 times, what will happen to current? Current will decrease by 100 times. Now this is current. So this is V, this is current. How much is heat loss now? Heat loss is equal to square of the current, I²R, square of the current 100 into R. How much was this? 10 to the power 6 R. This was heat loss in first case, this is heat loss in second case. 10,000 times the heat loss is less. This is because what I have done, a very small thing, voltage I have increased. So for any given power, when we increase the voltage, the current will become less and the heat will become square times less, very, very less. Why we want it? Because in my powerhouse, we are producing 1 lakh or say 10 lakh watt, that is 1 megawatt, 10 lakh watt. Say if my cost is 1 rupee, I am producing it for 10 lakh rupees. Now if I send it to this village which is far away, and there 10 to the power 6 R, if R is 0.5, then this is 5 lakh. 5 lakh watt is out, radiated out in the form of heat. In the form of heat, 5 lakh watt is out, and what this receives is only 50%, 5 lakh watt. I produced 10 lakh. What reaches here? 5 lakh. 5 lakh is gone in the air and all money is waste. here what will happen? Out of 10 lakh, only 100 is lost, or say 50 is lost. How much is received here? Complete 10 lakh. What appears attractive to you? 10 lakh, 10 lakh, 10 lakh, 5 lakh received, 5 lakh goes in the air. So naturally, nobody would like to throw out his money like this. Money, resources, labor, everything. So, for transmission, we have made a rule that transmissions will be done only at very high potential, so that current become less, and with the smaller current, the heat losses will be very, very less, negligible. This is this potential change increasing is done by transformer. This is the work of transformer in power transmission. And transformer works on what basis? Change of flux. Change of flux is due to changing magnetic field. Changing magnetic field is due to changing current, and changing current is what? AC or DC? It is only AC. DC do not change. So, with only AC, this transformation is possible. With only AC, we can save this energy, 5 lakh. Had it been DC, we cannot use transformer. We have to send it at the same voltage. We have to incur the losses of so much. So, this is the advantage of transformer. How much money, how much resources we are saving with help of the transformer. Okay. So, this is one use. The other use of transformer is step down. In step down transformer, we get lot of current. Why? We have decreased the voltage. If we decrease the voltage from 1000 to 10 volt, then the current will be 10 to the power 5, and when we make square of it, it will be 10 to the power 10. Such a large current. For such a large current, the heat produced will also be very large. This we are using in our spark welding. You have seen the welding done by electrode. We take a very high current, thousands of ampere, and we pass it through this air gap. This becomes so hot that all this metal melts, become liquid, and when it becomes liquid, it is very easy to combine them. This is a metal piece. This is another metal piece. Now, if we join the two, they will not get joined. You will again separate them like this. If we want to join the two, they will not, because they are solids. If they are liquids, water and milk, you join the two, water and milk, you can't separate them. And after that, you freeze them. That will be ice, and that will be one piece ice. You can't separate water and milk. That means liquids can mix, solids cannot mix. So what do we do? These are two iron pieces. We put one electrode here. This we are connecting with AC, and we give a supply between the two. And this supply is coming from transformer, and voltage is low, current is very high. How much current is passing through this? 1000 ampere. If 1000 ampere current is in this area, then this becomes very, very hot. So hot that this, everything melts out. And all these things melts out, they become liquid, and we know liquid mix up very well. So here, all the liquids, they mix up, and whatever is the gap, that gap comes from metal of this electrode. So this is filled up with all molten metal, and after that we leave it. When we leave it, that molten metal, it solidifies, and what we get is welding done. So what we need for welding done? Very high heat. What is very high heat? With very high current. How do we get very high current? Because we are using a transformer to decrease the voltage, and we get a very high current. So this is one use of the transformer. Other step down use, we all are using, stepping down 220 volt to 5 volt and using it through USB. In our computer, mobile, everything, we are using a step down. Whatever charger you have seen, if you see inside the charger, there is a transformer. Every charger has a transformer, and after that transformer, there are semiconductors to convert it to DC. That we will study in the semiconductor chapter. So these are the uses of transformers. One more thing about transformer. Do we get 100% energy from input to output? Answer is no. There are always losses, and for this remember a thumb rule. What is the thumb rule? Whenever you are changing the form of energy from one form to the other form, there is always a loss, and this loss may be very high loss, this may be a very small loss, but without loss you cannot change energy from one to the other form. Okay, that means if from coal you heat up your water by just burning the coal, get the heat, the coal will heat up your water 10 liter. If you convert that coal, send it to powerhouse, they will make electricity, that electricity will come to your house. For the same coal, convert it to electricity, because there are conversions from coal to chemical energy to heat energy of the steam, heat energy of the steam to mechanical energy of the turbine, mechanical energy of the turbine to electrical energy in the generator, and through the transformers it comes to my house. I put it in the geyser. When it goes to the geyser, then geyser heats up the same water. When geyser is heating up the water, I take the water heated up. How much water is heated? 1 liter, half liter, that's all. When I was heating directly, it was 10 liter. So much, 90% of the energy I have wasted because I want comfortable geyser and I don't want to heat on the coal. So much are the losses or the cost we are paying for transformation of energy. Anyway, so in this, when we are simply changing the voltage, are we getting the same energy here? Answer no, there are certain losses. What are the losses in a transformer? We will just write in very brief. Okay, let us see the losses in transformer. Number 1, flux loss. Flux loss is what? When this is making a flux, the 100% flux we think is connected with this, but it is not always so. Maybe there is a possibility that one line goes out, one line out of millions. Even if one line goes out, magnetic field lines, due to certain reason, then that is a loss not converted into energy, and such loss will be known as flux loss. Normally, we do not allow it to happen, but it may happen. Anything is not foolproof or 100%. Okay, so that is flux going out. Second is iron loss. In this iron, there are eddy currents. Whenever we change the magnetic field, there is a opposition from the iron and its electron makes a small eddies in it. That is known as, here they form the eddies. Here they form the eddies. Here they form, the electrons move like this and they form eddy currents, and these eddy currents generate heat. This heat is a loss. We are not using that heat. So this is iron loss. Eddy currents, heat. Then there is copper loss. These copper, lot of current is flowing through them and they have got resistance. You say copper is a very good conductor, very good, but still the resistance is not zero. It has certain resistance, and if there is a resistance and there is a very high current, then some heat has to be there, because this is not zero. So heat is never zero. There are certain losses of heat, and that is copper loss, because the current is flowing in the copper and the heat is generated through the copper. After that, hysteresis losses. Hysteresis losses we have studied in the topic of hysteresis in a lot of detail. So that is due to magnetization and demagnetization. Because of that, there are losses in it. Please see the lecture on hysteresis. You will see magnetization, demagnetization, energy is lost. That happens in transformer, and in that lecture I told you again and again that this will come again in transformer, where you will find that this is very frequent, 50 times in 1 second. So much is the hysteresis frequency, and there are so many losses. We can't help it, it has to be there. Then sound losses. Whenever there is a magnetization, demagnetization, whenever there is a magnetization, all these strips, all these strips which are tied together due to magnetization, they just make a gap between them due to repulsion. And when there is magnetization, they make a gap. When there is a demagnetization, that they join together. Gap, join together. Magnetization, demagnetization. Magnetization, demagnetization. And this is just like clapping. So this is a sound. This is the sound in two metals, what you hear when you pass by a transformer. This is the sound you hear when you switch on a tube light. This is the sound you hear when you start a choke. So that goom sound, this is because of this. So these are small clippings, and they keep on vibrating with each other, and that sound of cladding or staples, vibration. So if there is a vibration, if there is a sound, sound is a form of energy. That is a loss of energy. That happens in this. Now, one thing, during the construction, we told you that this is a hard iron, soft iron core. But this soft iron core, this is made of staples. Staples, thin, yes, this is a thin iron, E-shaped iron piece. There is another iron piece, there is a third iron piece, fourth iron piece, hundreds of such staples. You have seen a stapler, inside there are staples, there are hundreds of pins just joined together. So these hundreds of these shapes are there, then all these E's are joined together and they are ripped here. All these joined together and they are riveted at these four corners. This we keep open for the practical purpose of winding it. We make the winding, then insert the winding here, then we close it, and after closing, rivet it. This becomes the transformer like this. So, what is the use of making so many staples? Answer, each of this staple is varnished, and after varnish, they are joined together. That gives them resistance which decreases the eddy currents. It will not allow eddy currents to form like this. This shape, E shape, because of this what happens? The eddy current has to move a very large path like this. This path has increased 2 times. If this path has increased, resistance has increased. If resistance has increased, then current has decreased. If current has decreased, then heat is decreased. This is how we decrease the heat due to eddy current. Now, it is from this side, but if we want to decrease the heat due to this current, then this current is also to be decreased. How do we decrease this current? We add up so many staples one after the other, and between these two staples there is varnish. varnish, 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 all the staples are joined together, and varnish is a bad conductor, and due to bad conductor, this current, eddy current, become less because the resistance of varnish is large. So we reduce this current by giving it this shape, not keeping this shape. This has got 1R, 2R, 3R, 4R. In this, eddy current has to make 1, 2, 3, 4, 5, 6, 7, 8. 8, these are 4. Double the resistance. On this side, because of varnish, there is double the resistance. So we decrease the eddy currents, and therefore heat becomes less. This is the purpose of staples. Staples. So this was left when we were studying description. This comes in description, and the purpose is to reduce the eddy currents, that is iron losses. Okay, so this was all about losses, application, and most important application of the transformer. Only one application. What is that? Increasing EMF so that AC can be transmitted. So transmission of AC is possible with transformer, and the transformer acts only for AC. Therefore, only AC can be transmitted to large distances. Thank you.